All right, guys, so we got tangent lines and derivatives, part 2 of what we did. You started yesterday. So here we go. This time we're going with the second word here. We're actually going to go with the derivatives. Yesterday we did tangent lines, today derivatives. That's why it's part 2. All right, we saw this yesterday, this limit, as a way that we could find the slope of the tangent line, pretty easily. That would end up being the best way we could go with it. And turns out it shows up in a lot of other contexts as well, including today, just saying. All right, it shows up so much we give it a name, and the name of it is called a derivative. The derivative of a function at a number a, and this is the symbol for it, with like a f little apostrophe a, is that limit, okay, as h approaches 0, if it exists. If it exists, the derivative exists. If not, then it doesn't, but hopefully it does. We're going to show you a couple here. All right, find the derivative of f of x equals this function, f5x squared plus 3x minus 1 at the number 2. Okay, so what I'm basically going to do here is I'm going to set up limit as h approaches 0 of f of 2 is my x. So instead of x plus h, I'm going to go 2 plus h minus f of 2 all over h. I'm just going to work that thing out. So first thing I got to do, obviously I got to plug in the 2 plus h. So when I plug in the 2 plus h, it's going to look like 5 times 2 plus h squared plus 3 times 2 plus h minus 1. And then I'm going to plug the 2 in. If I plug the 2 in there into that function, I'm just going to get I'm going to get 25. So minus 25. I just plugged it in my head real quick. And h. All right, so now I got to work all that algebra out here. I'm going to work that. If I square 2 plus h, remember that's square, multiply, double, square. I can go ahead and distribute that 3 minus 1 minus 25. That's really minus 26 out there. Over h. Keep on going. This is it's not hard, it's just the work part of it. That's 20 plus 20h plus 5h squared plus 3. So I'm going to go ahead and combine that 6 and the 26, make it minus 20 out here. And over h. I got to make this a little smaller. Okay, hopefully 1 or 2 more steps here and we got it. Limit as h approaches 0 of, notice the 20s cancel. That leaves me with a 5h squared and a 23h over h. Now also notice that the h's cancel. Make it smaller one more time. So it gives me the limit as h approaches 0 of 5h, that's not an h, 5h plus 23. There's my limit. All right, now, because that is a polynomial, you can do direct substitution, plug that in. And if you do that, you get 23. So the derivative of that function at 2 is 23. Look at another one. Also, before I get started on this one, realize the last slide we just did, we got the derivatives 23, and because we did the same, formula or system that we found the slope of the curve of the tangent line yesterday at a point, that's also the slope of the tangent line on that parabola at the point 2 would be 23. So that's also that slope. All right, that's kind of a big deal. Should have said that on the last slide. Let f of x equals square root of x. It says find the derivative of a, and then find derivative of 1 and 4 and 9. So let's find derivative of a first. This may take a second. Derivative of a, we're going to go limit as h approaches 0. And remember, we're going f of x plus h, which in this case is a plus h, minus f of a over h. That's our little formula there. So let's just start working through. I'm going to put a in there. It'll be square root of a plus h minus square root of a over h. All right, so I'm going to have to rationalize that to simplify it. So I'm going to recopy it down here, a plus h minus a over h. Now I'm going to multiply by the conjugate of that, and that's a good strategy to use a lot. A plus h be plus square root of a, and you got to do the same thing to the bottom, to your denominator. Okay, and when you do that, when you multiply by the conjugate, it should be h. On my numerator, remember, if you multiply conjugate, it's just FL, it's fl, so you get a plus h minus a, which is going to work out really good. In my denominator, I have h times all this stuff right there. And notice in my numerator, my a's will cancel. So I'm sitting here looking at h over h on the square root of a plus h plus square root of a. Limit as h approaches 0. Now, also notice right there my h's will cancel. And if I cancel my h's, got to make this a little smaller again. H's cancel. I get the limit as h approaches 0 of 1 over the square root of a plus h plus the square root of a. Now, if I work it out, because it's a rational function, right, I'm allowed to do direct substitution, so I'm going to plug a 0 in for the h's, and I would get this. I would get 1 over square root of a plus square root of a. So my derivative would be 1 over 2 on the square root of a. Okay, so the derivative of a, this right here, I'll about wrote it again. The derivative of a would be 1 over 2 on the square root of a. All right, now let's try one at a number here. Let's try the b part. It says derivative at 1. Let me erase what I have here. Find the derivative at 1. So the 1 would look like this. If I do the derivative at 1, I'm going to have f of 1 plus h minus f of 1 over h. I forgot the limit. Limit is h approaches 0. Right? So we go limit as h approaches 0. I'm going to plug 1 plus h in there. I get square root of 1 plus h minus the square root of 1 all over h. Now the square root of 1 is 1. All right, so I'm going to get limit as h approaches 0 of square root of 1 plus h minus 1 over h. I'm going to do what I did just a second ago. I'm going to go ahead and multiply by the conjugate of the numerator, 1 plus h minus 1 over h. So I'm going to multiply by square root of 1 plus h plus 1, square root of 1 plus h plus 1. FL on the top, which is just 1 plus h minus 1. On the denominator, I'll get h and square root of 1 plus h plus 1. So my 1's cancel up top. My h's are also going to cancel right there, so I'm going to go limit as h approaches 0 of, that just leaves 1 on the top, and this one on the denominator, 1 plus h, that's a 1. Sorry about that, let me make that linear. 1 plus h inside, plus 1. Move it up a little bit. And now, because it's rational, I can do direct substitution. That gives me 1 over square root of 1 plus 1, which is 1/2. All right, now, I know you're sitting there thinking, golly, that's a long process. And you're right. But that's how we got to roll with it. So there you go. I guess I should say sorry about that. So sorry about that. All right, early in the year, it's a little bit different, but the same. We talked about the average rate of change. Like when you're looking at curves, we've got to do the average rate of change. What we did is we still did the same thing, like y minus y over x minus x, which is what this stands for. So we do f of x, which is really y, minus f of a over x minus a. That's what we did early in the years, way, way back. Hope you kind of remember it. So if we do the same thing here, if we do the average rate of change, but put smaller and smaller intervals together, these are called instantaneous rate of change. That's a big deal. Instantaneous rate of change. And you won't believe this, the next slide. The way we find the instantaneous rate of change is, are you kidding me, at point A, is the derivative. Except instead of being h approaches 0, we're going to go x approaching a, x approaching that number. So it's that same formula we've been using. I put a big star down here. So look what all we know about the ways of interpreting what's called the derivative. The derivative is the slope of the tangent line at that point. It's also the instantaneous rate of change, which means rate of change means slope in respect to that point A. So different terminology for really the same thing. All right, instantaneous rate of change is slope, tangent line to a curve. Okay, so let's look at one example. Okay, it says if an object is dropped from a height of 3,000 feet, its distance above the ground in feet after t seconds is given by this. This is how high it is, just dropping something down. Find the object's instantaneous velocity after 4 seconds. All right, so the velocity after 4 seconds, we need to find, first of all, what h of 4 is, because that's what the height's going to be. So I'm going to put in 4 right here for 4 squared. That's going to be 16 times 16 minus 3,000. That's 2744 feet. That's how high it's going to be after 4 seconds. So it's still quite a ways up in there. Of course, 3,000 feet is pretty high. Okay, so what I need to find the instantaneous velocity is the derivative at 4. Okay, so that's going to be, remember the formula, it's going to be h of t minus h of a, or 4. 4 is a is the number they gave me, and then t minus 4. That's going to be how I'm going to do the derivative here. So h of t, and I keep forgot to write the limit. So that's the limit as t approaches 4. Okay, so let's work this out a little bit. So I'm going to have the limit as t approaches 4 of h of t, which is this, 3,000 minus 16t squared, minus h of 4. We just found out h of 4 a second ago is 2744, and all that's over t minus 4. All right, so if I do a little bit of work on my numerator and combine my 3,000 and 2744, I get this. I got a limit as t approaches 4. That's going to be 256 minus 16t squared over t minus 4. Now, the amazing thing in my numerator is it factors. All right, so I can take out a 16, and it's going to leave me with a 16 minus t squared over t minus 4. All right, keep on working. It's a lot of work. Limit as t approaches 4. I can keep factoring my numerator. That's going to be 4 plus t and 4 minus t over t minus 4. And one thing about this is I can cancel the t minus 4 and 4 minus t because they are opposites, but because they're opposites, they cancel not to positive 1, but to negative 1. So my limit as t approaches 4 boils down to negative 16 times 4 plus t. And because that's a polynomial, I can take the 4 and direct substitute in there and make it negative 16 times 8. Everybody knows that is negative 128. Now, what is that? That's how fast it's falling. That's the velocity, the instantaneous velocity at 4 seconds. So that's feet per second. It's falling at 128 feet per second at that time. The negative sign right there, I know speed can't be negative. That just means it's falling. So really, we really should say the speed is actually 128 feet per second. All right, man. I know if you made it through that, I'm proud of you. I hope you did. This may be a video better to watch after the lesson than before, but I'm glad you watched it before, and we'll work on all this stuff tomorrow. It does a lot of work. I can't deny that. You have to go through the steps. You just have to. So I guess I'm apologizing in advance. I can't make it any shorter for you, and we'll work on it tomorrow. See you then.